When finding the solution to a system of equations, you can often find that solution by taking one of two different points of view. So here's a system of equations, and let's give this some context. Let's say that there's one person who's traveling at 3/4 of a mile per minute, and this negative means the direction. So they're traveling in this direction, going from 4 miles. Let's say they're 4 miles away from a restaurant. So they're traveling towards the restaurant at 3/4 of a mile per minute. And another person is traveling towards that same restaurant at 1/8 of a mile per minute. So the 2 points of view are, you can view A as traveling towards the restaurant, and it's really catching up to B. So A is catching B. And at some point, A is going to pass B before they get to the restaurant, and then they're going to meet at the restaurant. A is going to get there in a little over 5 minutes, and B is going to get there in about 8 minutes. But at some point, they will be the same distance away from the restaurant because A has caught B. The other point of view is that B is being caught by A. So you're B and you're traveling towards the restaurant and kind of looking over your shoulder, seeing that A is catching up to you. From the point of view of A, you're looking ahead and seeing that you're catching B. So if you have the A point of view, then you're starting out 3 miles behind. So this 1 minus 4, this 1 mile minus 4 miles is a negative 3 miles. If you have the point of view of B, you're starting out 3 miles ahead. So this is 4 minus 1 is a positive 3 miles. Now the rate at which they're closing the distance between them, for A moves forward 3/4 of a mile. So in 1 minute, it's 3/4 of a mile closer. A second minute, 3/4 of a mile closer. But at the same time, B is inching ahead by 1/8 of a mile. So the total distance that they close this gap for each minute is really the negative 3/4 minus that negative 1/8. So it's a negative 5/8 of a mile closer each minute. Now from the point of view of B, B is going ahead by 1/8 of a mile every minute, but looking over their shoulder, they're seeing that A is gaining on them very quickly, so 3/4 of a mile in that same minute. So even though A goes ahead, that gap gets closed by 5/8 of a mile every minute. So this is a negative 3, and you're asking the question, how many times can you take out negative 5/8? How many minutes is it going to take to close this gap of 3 miles? Or this is a positive 3, and how many of these positive 5/8 can you take out of a positive 3? So every time you do that, that's 1 minute. So how many minutes is it going to take to close that gap of 3 miles? So in one case, from the point of view of A, that's a negative 3 divided by negative 5/8, and that equals a positive 4 4/5 minutes. So in 4 minutes and 4/5 of a minute, which is 48 seconds, by the way, 4 minutes and 48 seconds, they will both be the same distance from the restaurant. So from the point of view of B, it's 3 miles divided by 5/8 of a mile per minute. So again, it's the same 4 minutes and 4/5 of a minute that they will be at the same distance from the restaurant. Now, when you solve this algebraically, if you work from the point of view of A, you're going to see a negative 3 in the calculation, you're going to see a negative 5/8 in the calculation, and you're going to see the answer, the solution of x is equal to a positive 4 4/5. If you solve the problem from the point of view of B, you're going to see a positive 3 as you work through the algebra, a positive 5/8 as you work through the algebra, and again, the same answer of 4 minutes and 4/5 of a minute, or 48 seconds. All right, so here are the two equations, and you can take these two expressions and set them equal to each other. That's using the transitive property. They're both going to be the same y coordinate away from the restaurant, but one expression is the negative 3/4 x plus 4, and the other expression is a negative 1/8 x plus 1. So those are equal to each other when they are this distance away from the restaurant. So what's the x value to get to that distance? Here's from the point of view of A, so here's the negative 3 miles, and here's the negative 5/8 miles per each minute. So how many of these negative 5/8 are there in negative 3? That's this division problem. How many times can I get a negative 5/8 out of negative 3? And from the point of view of B, here's the 4 minus 1 or 3 miles. That's right here. And this gap is closing at 5/8 of a mile each minute. So how many of those 5/8 of a mile are in the original 3 miles? In both cases, you're going to get an answer of 4 minutes and 48 seconds, or 4/5 of a minute. Now you can also figure out, you plug this value for x back into either one of these equations, and you're going to find that the distance they're away from the restaurant when they pass each other, when they're the same distance from the restaurant, is 2/5 of a mile. So you're going to see that y is 2/5 of a mile. And further, if you calculate how long it takes A to get to the restaurant, just set y equal to 0, figure out what the value for x is, and you're going to find out that that's 5 1/3 minutes, or B takes 8 minutes. So you set y to 0 and figure out the value for x when y is 0, and you're going to get an answer of 8 out here. So A travels, catches B. They're the same distance from the restaurant. After 4 4/5 minutes, they're 2/5 of a mile from the restaurant. A gets there first in 5 1/3 minutes. B gets there second in 8 minutes. The reason for doing this is just so that you can see you can solve this problem from two different points of view, working with negative 3, negative 5/8 to get to 4 4/5, or working with positive 3 and positive 5/8 to get to that same positive 4 4/5 minutes in this case.